Hello, security pros. Good afternoon. Thank you for joining us on today's ESA webinar, To LTE and Beyond. Telguard takes you through 2022. Unless you've been living under a rock the past few years, we don't have to tell you there are cellular technology sunsets on the immediate horizon, or that you need to upgrade older tech alarm communicators that will simply stop working. We all know it, but do we know there's more than one solution available? I'm Riley Hogendorn, and I'll be facilitating our discussion today. Before we dive in with Daniel Rosales and Marshall Lorden, our experts today from Telguard, I'd like to provide some tips for those of you that are joining us on your first ESA webinar. First, welcome. ESA, or the Electronic Security Association, is the largest and longest standing association serving the pro-installed electronic security and life safety industry. Our members are integrators, dealers, monitoring centers, and even manufacturers and service providers in the space. We are the voice of the electronic security and life safety industry. If your company is a member of the association, thank you. We hope you're taking advantage of your ESA benefits to leverage growth and connections for your team. If your company is not yet an ESA member, check us out. You'd be surprised at the power of membership. Get a feel for all of the ESA benefits, including savings on business insurance, training, sales team coaching, certifications that satisfy state licensing, and more at esaweb.org. All attendees will be muted for the duration of this session, but that does not mean we don't want to hear from you. If a question or comment comes to mind at any point during today's session, click the Q&A icon at the bottom of your screen, and we'll send the questions to our experts today. There's no need to save those questions until the end of today's presentation. If something pops up, go ahead and ask, and we'll ensure we have time to address your questions. We'll also be recording today's webinar so you can rewatch the on-demand session and share it with your colleagues. We at ESA realize your time is valuable, and we appreciate you spending some of that time with us today. Without further ado, I'd like to introduce Daniel Rosales and Marshall Lorden. Daniel has a degree in computer engineering and currently pursuing his MBA. With over 13 years of expertise, Daniel oversees the top-of-class technical support department and the product management team for Telguard as it builds the foundation for the innovative efforts that Telguard is known for. He played a key role in the development of the first commercial Fire Soul Path communicator, as well as its technology transitions. As a technology-minded member of the industry, Daniel has been able to facilitate multiple lectures and in-depth educational sessions on broad topics relating to NFPA 72, cellular evolution, emerging technologies, and their application to IoT, security, and life safety. Marshall started his role at Southeast Regional Sales Rep for Telguard in 2016 and now has more than 5 years of experience in the industry. He oversees Florida, Georgia, Alabama, and Mississippi with the goal of promoting the Telguard product line and guiding dealers through the 3G and CDMA sunsets. He's very active with many security associations, including the Georgia Electronic Life Safety Systems Association. Daniel and Marshall, let's dive in.
All right. Well, I appreciate the intro. My name is Marshall. I am Telguard's Southeast Sales Representative. I'm glad to be here today to talk to you guys. I'm here with Daniel Rosales, Telguard's Director of Technical Services. Before I get started, I want to say thank you to ESA for the opportunity to share this information. I think ESA does a lot of great work in the industry, and I'm always happy to partner with them in stuff like this. So today we're going to be talking about, our topic is to LTE and beyond, generating recurring revenue with different communications paths. And in the way that I want to talk about this is answering the questions, who is Telguard? Where do we fit in the industry? How have we created solutions for our dealers in the past? I want to talk about why phone lines have been so prevalent in the industry, where they fit as a communication path in the past, how cellular or even Ethernet can be a viable alternative to a phone line solution? And then what solutions does Telguard provide that solves problems for our dealers in the future? And to answer the first question, who, I want to talk a little bit about Telguard as the alarm communications experts. To me, Telguard, what that means is that we're always at the forefront of the cellular technology in the industry, coming out with the latest generation to help our dealers stay on top of it. And it also means that we are going to be experts and a resource for our dealers and for AHJs to train them on this equipment. So that way they're more educated when they come across it in the future. That way they're more prepared to install this equipment or to tackle upcoming challenges like cellular sunsets. And going back into 1980s, 1986 is when Telguard was first founded, and we produced the first cellular communicator for the alarm industry. I still actually get phone calls from dealers who tell me how they would use a phone butt set to dial in the alarm programming codes. Things are a lot faster now as we've iterated the technology over the years. In 1999 is when we came out with the analog version of our communicators. Moving forward to 2005 is when the 2G network arose, and we came out with our 2G cellular communicators. In 2010 was we released the TG7FS, our flagship sole path commercial fire communicator, the first in the industry. Still used heavily today. As we've updated the cellular technology in that. 2012 is when the 3G network first arose, and we started producing GSMs for all of our dealers. 2016 is when I first came on board. I was helping a lot of my dealers with the 2G sunset, helping them upgrade over to 3G or the recently released at the time 4G LTE communicators. And 2021, today, I'm working with dealers again as the 3G network and the Verizon CDMA network are beginning to sunset. And I've been training teaching dealers techniques on how to approach all of their accounts, how to upgrade their 3G over to the latest 4G LTE, or we'll talk a little bit about the 5G LTE-M technology that's out now. And next, I want to ask why phone lines are going away, and ask if there is a better way moving forward.
Thanks, Marshall. So I'll take over here. So my name is Daniel, as we were introduced earlier. I've been with Telguard for actually 14 years now. So in the industry, have a little bit of experience. And one of the things that I've noticed over the years is that there's always this lingering feeling that POTS is going away, but it never really truly feels like it's going away. So I want to dive a little bit into what POTS is, right? It's been in our minds and physically present in some fashion since the 1880s. The truth of the matter is that POTS hasn't really evolved too much. It's still using the same twisted pair copper wire system. What we know as POTS, it's basically that, the same technology, conceptually speaking, that was conceived back in the early 1900s is still prevalent today when we talk about POTS, when we talk about the POTS that our alarm panels and our fire systems want to use. When we talk about the technology that we are actually seeing today compared to the technology that we are expecting, that's where things get a little bit muddy, it gets a little bit complicated. When we talk about POTS, we want to make sure that we emphasize that it is a connection between point A and point B. So when you get on the phone and you dial into your mom, you dial into your uncle, you dial into a friend across the country, you're not establishing a direct connection to their phone, right? You're basically going through different nodes or hops, which we call switches in the industry. As you go through these switches, you're basically getting connected to whoever you're dialing into through different paths, different routes, different communication routes. One of the problems that we're facing today is that there is a transition going away from what we generally know as traditional POTS Again, what we're used to, twisted pair, what we're used to, tip and ring, what we're used to, voltage between 48 and 52, and it's slowly transitioning into a digital version of it, right? And it's all fine and dandy. It's great. It works great for you to make phone calls. It works. It has voice encoders and decoders, digitization that actually makes the conversation better, because some of it can, some of the technologies implemented can actually get rid of some of the background noise. It can make it a lot better. It can make it encrypted. It can make it more secure. There's a lot of benefits to it. But to the industry that uses analog type connections, let's talk about your radionics formats. Let's talk about your dial-up, your old school 4231. Let's talk about your tonal type of signaling, like DTMF tones, like contact ID that we're used to. Digitization of these analog type transmissions doesn't play well. And if you've ever encountered a transition from a system that was working fine for 15, 20 years, all of a sudden the signals are missing, or you're getting late to tests, or you're getting just overall, missing signals for an extended period of time, all of a sudden getting dumped a bunch of signals. It could be because there is a bit of a digital transition going on. Now, it's easy enough to spot a digital transition when it happens on the front end. And when I mean front end, I mean when you're installing a product, right? You're installing a unit, you look at it, you say, hey, where's your demarcation point? Let's see. And you start tracing the cables, tracing the wires, and you see a modem. You see a cable modem, you see a phone modem. Right away, you know, this is a digital line. Or very simply, you start metering, you start measuring the voltage. Oh, this is giving me 25 volts. This is not what I'm used to. This is a digital line. So it's easy enough to understand on the front end transition when somebody changes, somebody willingly chooses to change the connection from standard phone line to a better priced, more economical digital version of it, that again, for all intents and purposes to the end user, feels the same. But for us in the industry, in the life safety and security industry, it doesn't work quite the same. It doesn't have the same success rate. When we talk about the way that POTS works, I mentioned that as we make a phone call from point A to point B, we go through different nodes and switches, right? So we can spot the front end transitions. We know when somebody changed their phone company, but we don't know, we can't really spot, it's not easily identifiable when a switch along the path has changed. When a carrier has made a decision to say, you know what, I have to cater to my customers. I have to make sure I create enough revenue. I have to make sure that I have enough to maintain this switch. And it makes better sense for me to make it a digital switch, and any communication coming in, doesn't matter how it's getting to me, doesn't matter how it's getting to my switch, I'm going to digitize it and then switch it back to analog, right? So we can identify when a company chooses to have a different service provider, but when the service being provided has to change along the way, those are much, much harder to spot. And those are some of the problems that we're getting with telco connections fading away, but fading away in a very slow manner, is the fact that we're getting a false sense of security that, hey, that phone line, when I installed the product, that phone line is working great. That phone line checked out. I know 100% is analog. You 100% could know that the customer ordered that type of line, but there is absolutely no guarantee that the communication from that site to the central station will be analog all the way through. And that is where we start facing problems. So that leads me to kind of give you a little bit of an overview of what the Telguard advantage is, or what the cellular communication advantage, or to put it in different terms, a non-analog, a non-POTS communication. What's the advantage of having that? I'll take fire, commercial fire as an example, just because it has stricter requirements. So it's easier to identify what the benefits are. When it comes to commercial fire, we know that one of the requirements that has been standing for many, many, many years has been that we need to have a redundancy in place. We need to have two communication paths, and both of them need to be supervised, whether it's daily or some of the later revisions of code state 6 hours. We need to have some level of supervision that indicates either daily or every 6 hours, you send a signal through each one of those paths. And as long as that signal gets to the central station, it lets me know that that path is available and it's ready to send signals from the panel. when NFPA code introduced the option for a single path, for a single communication path, they needed to figure out a way to introduce a higher level of security, a higher level of insurance that whatever path you're using is going to be working. And that is where the supervision concept came in. So as a single path cellular option, what we had to do was essentially comply with a 60-minute supervision. And of course, there's a little bit more history behind it, which I can elaborate later on in the presentation. But what it comes down to is, if you go with a cellular communication or a communication path that adheres to the supervision level that is required from cellular devices, you're looking at a 60-minute supervision rate. So what does that mean? That if you're relying on redundant phone lines, you have a big gap, 24 hours on each line. You stagger them, you're gonna have 12 hours in between, 12 hours where if the panel is quiet, central station is not gonna get anything, and they're not gonna worry about it because that is expected, right? Meanwhile, within those 12 hours or within those 3 hours, if you're using the 6-hour supervision, you can have something very bad happen that impacts both lines and that impacts that system's ability to transmit. Now, take that and put in a cellular communicator in place. What happens with a cellular communicator is that we are mandated to supervise that connection to the point where if it gets to 60 minutes of an interruption of service, we have to let the central station know. So at this point, we're looking at an argument, basically 60-minute supervision. You get to know that something is wrong within 60 minutes of that cellular connection being bad versus 6 hours, 3 hours, or 12 hours, depending on how you have it set up for the panel side, of you assuming that something is right. Now, I get the question quite a bit. Well, you're working with redundant lines, so yeah, one of them is going to go bad, but what are the chances the second one goes bad? My argument back is, have you ever traced a phone line? Have you ever tried to run 2 phone lines and trace back to its origins or trace back to where that phone call goes? I mentioned switches before. Switches are just going to be redundant, are just going to be switches that you hit on every single time you make a phone call. So there is absolutely, once again, no guarantee that with a phone line, you order 2 commercial phone lines, there's no guarantee that those 2 phone lines are not going to hit the same switch at some point. So how redundant are you if you have one or multiple single points of failure, right? So that's something to think about as you start building up an argument for a single technology like cellular, and replacing 2 redundant versions of the same technology like POTS. One of the other, I guess, questions that we get, what's another benefit for it? One of the items that we don't really think about until it happens to us is that with a technology like cellular, with a communicator like Telguard, you have control of the path. It doesn't, at surface value, it doesn't seem like it means much. Control of the path, what does that mean? I mean, I own the unit, great, whoop-de-doo, what's the advantage there? The advantage there is that you're not gonna have to rely on somebody else making sure that your phone lines stay the way they are. You're not gonna get that call in the middle of the night because the fire system is going bananas because it can't send something out. And of course, you're the one that installed the unit, so it's your fault that somebody at the property went ahead and gave Comcast or Charter the go-ahead to replace their phone lines with digital lines, right? So with having a communicator that you are solely responsible for, you are taking away that power from property managers. So forget about recurrent revenue. I know Marshall will tell you a little bit about how much money you can make and how the dollars are going into your pocket instead of a telephone company. From a strictly technical and service perspective, you have control of the path, taking it away from a property manager, from a business decision that could really, really damage your brand. And that's basically what we're all about. So how do we do this? Cellular and internet, we are basically pushing out alternatives to POTS connections. I want to really focus a little bit more during this webinar on the technologies themselves. Yes, we're going to talk about Telguard. We're going to talk about the products. We're going to do a quick overview on what Telguard brings to the table, the different residential and commercial applications. But I really want to focus a little bit more and spend a little bit more time on the technologies that we're currently pursuing and the technologies that we're currently developing. So LTE-M is the technology that Telguard has chosen for the foreseeable future as our go-to technology. Now, this technology actually has been around for a couple of years, so it's not brand new. One of the things that Telguard likes to do is be innovative, right? We like to be the first to the market with different things, but we don't want to be the first for the sake of being first. We don't want to be the first for the sake of saying, hey, we did it first. Here we are, Telguard #1. It's not just about that, right? We wanted to make sure that the carriers in question had made the appropriate decisions to expand coverage, had made the appropriate investments with enrollment partners to make sure that we have everything in place for it to be a serviceable service for us. Now, what is CAT-M, LTE-M, CAT-M1? They're all synonyms of one another. What does it actually mean? It's a different technology that is based on LTE platform, right? But it is not LTE. And the reason why I want to make that clear is that CAT-M, CAT-M1, LTE-M, whatever you want to call it, is a technology that was specifically designed for the IoT world. It was specifically designed for the industry that security and fire safety is a part of. So if you take a step back and take a look at our products that we've had over the years, the 3G products, the 2G products, the analog products, even the LTE products that we have, they're all basically living in an end user consumer iPhone, Android world, right? So we're basically using the technology that, guess what, was created, developed for those type of users. So when you start looking at LTE, when you start talking about the 5G networks coming out for AT&T and for Verizon, what are the things that come to mind? Speed, how much can I stream on it? How fast can I download? Well, those criteria don't really make too much sense for our industry, right? For as far as delivering a signal, you know, we've all been doing this for a while. It doesn't take 1 gig of data to deliver a single alarm. It takes very minimal data. So what do we need? We need reliability. We need it to go fast. We need it to be available. We need, more importantly, we need it to be able to get from point A to point B as a small packet of data. We don't need to start a download of a video, particularly not for what we need. And that's where CAT-M comes into the picture. CAT-M, LTE-M comes into the picture, understanding that there's a subset of the industry. There's one part of it that requires tablets and iPhones and Androids and 4K and Retina display and all these other things that require massive amounts of data being consumed and being delivered at a fast pace. On the other hand, you have this other connected service, right? You have your connected cities. Think of a parking meter. It's a perfect example. It doesn't really need to do much except maybe once a day. It needs to send information back over to say, hey, I'm full. I need somebody to check me out, right? So think of a device that needs to only transmit very small packets of data. What does it need? It needs to be reliable. It needs to get out fast. It needs to have very low consumption because it doesn't need to, you know, if you look at a parking meter, you don't want to change the batteries on the parking meter every month, right? You want it to be self-sustained, self-contained, and you want to maybe change it every couple of years. So some of the criteria that came together as 3GPP and other smart folks within the technology world came together to put together the requirements for LTE-M performance, we're looking at that scenario. Devices that need to be smart enough to communicate, but they're not going to be interfacing in the same way that your tablets, Androids, and iPhones would. So that is what really opened the world for us as a technology, as an industry using the technology to deliver small basic messages, to really deploy this as a 4G service that transitions into 5G. Again, part of it is, if you think of a parking meter, right? Once you set up a parking meter, you really don't want to change it for the next 10, 20, 30 years. You want to make sure it works and it keeps working. So taking that into account, and we're talking about connected cities as being the platform for LTE-M, you look at a technology that was developed to be able to support the transition from 4G into 5G. So why did Telguard wait a couple of years, or why did Telguard wait until you know, this year or last year to start promoting this as a viable technology? Number one, we had very serious conversations with our carriers. If we're gonna go all in with a technology, if we're gonna promote a technology as a technology of the future, we want to make sure we have the back end of the carriers. We want to make sure that AT&T and Verizon are telling us, yes, this is the way to go. here are reports, here's the data that shows that, hey, yeah, 99.999% is just as good, if not better. We want to find out, hey, based on the metrics that you have from other deployments out there, what are we looking at? Are we looking at better signal penetration? Are we looking at a lesser signal strength to expect? We have all the right answers. We got all the right answers from the carriers, and even within our own statistical analysis, most of the units that we have deployed with the CAT-M radios today, with the LTE-M technology, they are averaging about half a bar to a bar better signal strength than our standard LTE units in similar scenarios, right? So we are very happy with the performance today, but what we're most happy about is the fact that LTE-M technology does not share the same sunsetting concerns, I guess, if you will, that you can get from LTE whenever that happens. And we're still far, far away from LTE even sunsetting. I don't think there's been a date set yet. So I would say 8-10 years, it's you don't even have to worry about it. But with LTE-M, it has the capability built in because of how the criteria was put together to transition into 5G, which gives us even more longevity than your standard LTE product, LTE unit. Now, we did recently add internet path as one of the viable options for communicators with Telguard. And this is a technology that's been around. It's been around for a while. We've listened to our customers. Voice of the customer is very important to us. And we've listened, we've gone back and forth as to the best approach to do it, the best way to do it. One of the major feedbacks that we've gotten is that when you start looking at and dealing with the financial segment, mercantile applications, you start looking at perhaps our end users, our customers, our mutual customers, looking at us and saying, hey, I don't really want your device on my network. If you're asking a network, a support person, anything that has to do with a firewall, they are going to ask you 21,000 questions as to, wait, what port is it using? Why is it using it? What is it using it for? What are the hacking and this and that? So one of the things that we wanted to make sure when we came out with our internet product, we wanted to make sure that we had access into the device via an unrestricted path. So what does that mean? That we're using the Ethernet connection. We're using a hardwired connection. There is no Wi-Fi for the commercial units. We are using a hardwired connection and is an outbound connection only. So there is no port forwarding that needs to happen from the network side of things for us to be able to get in and manipulate the device. That doesn't happen. And the reason for that is because we are very much aware that we want to make things as easy as possible. So what we are doing is we are always keeping a cellular connection available and ready to go. So even if Ethernet is your primary path with one of our dual path products, cellular will be the option that allows us to get into that unit and make the necessary changes or request that unit, hey, can you go ahead and call home because we need to do some evaluations. We need to get status reports, right? So everything is basically catering not just to the way that the internet allows us to do things, but to the way that our customer base is looking to do things like. And again, it was very important for us to make sure to make it as easy as possible, not only on the installation side, but also on the servicing side moving forward. I talked a little bit about fire. And again, fire is probably one of those very extensive topics. So we can go on for many hours talking about the different changes in code, but I wanted to just quickly run through it. Marshall mentioned during the intro that we have been in the commercial fire business since 2010. The truth is that we've actually been in it for longer than that. But we were in the commercial fire business as a backup option, as a second option to a phone line. It wasn't until 2010 that we actually got into the commercial fire business as a sole path option. And it was just a very major change in code that allowed us to be a single communication path, a single communication technology, provided that we supported the supervision rates that NFPA required. Now, back in those days, and again, I started with Telguard back in 2007. So I definitely lived through the early years of the commercial fire cellular boom. It was rough. 5 minutes was a very aggressive timeline for us to be able to tell a customer, hey, something went wrong. What we would encounter from time to time, it was actually more often than I would like to admit, was that overnight, as carriers were going through their own transitions, updating towers, going through maintenance, a lot of these maintenance events lasted more than 5 minutes. And the really, I don't know how to put it another way, the really annoying part about it was that a lot of these events would happen overnight, 2 or 3 in the morning. Of course, cellular companies have to cater to the majority of their customers, and majority of their customers are iPhone, Android, BlackBerry users at that time. So they would happen overnight, and there would be 6-7 minutes in duration. But what does that mean for our product? That because it lasted over 5 minutes, we had to get out there, contact the central station, say, hey, there's a failure. By the time central station started, going through the motions of what they needed to do, boom, we would send out a restore. So it got to the point where it was, there's no other way to put it. It was annoying. So much so that the folks at NFPA made a revision to the 2013 edition and bumped up the supervision code from 5 minutes to 60 minutes. Very wise, very smart decision. And that is the supervision rate that we've been going with since the 2013 edition. So 2016, 2019, no major changes at all to SoulPath. So we are sticking with 60-minute. And I believe for the most part, there's still some jurisdictions out there that are still working with 5 minutes. For the most part in the US, we're working with 60 minutes. Now, Telguard being a brand that services North America, both the US and Canada. Canada does have a little bit of a different requirement. They're actually 180 seconds. So if you are in the US and you are complaining about 5 minutes, Canada has it worse. When it comes to link supervision, how does it work? It's a very simple, very basic concept. And I'm sure you'll appreciate the basic principle behind it, which is basically once somebody enables link supervision, we are asking the Telguard unit to check in. Hey, just check in every few minutes. Just let me know you're alive. And our back end will actually take in that information and keep track of it to the point where if something goes wrong, or let's just say you turn off the unit to test it out, because we're not getting any packets of data, because we're not getting any supervision check-ins from the Telguard unit, we're going to keep that timer going and we're going to count, oh, it's been 60 minutes, got to reach out to the central station. By the same token, once the Telguard unit comes up and running, you turn it back on and start sending packets of data, our backend will notice, all right, there's the first signal. Let me go ahead and send an information to the central station to restore it. So this works in a very beneficial way to both to us and to the central station, because on the one end, we can more closely supervise the Telguard unit. And on the other hand, central station is not getting heartbeats every 5 minutes, 10 minutes, whatever. It's just getting the real alerts that come from our backend that tell it, hey, there's a problem. Hey, problem restored. And in between, you're going to get the real alarms, fire alarms, timer tests, or whatever else may come their way from a normal fire alarm system routine. So what do we offer? The Telguard solutions, what do we have? Before I get into the products themselves, I just want to tackle a little bit of the Telguard system and how that works. Not going to get too deep into it, but we basically take communications, right, from systems that perhaps we're not thinking can use cellular. Have a residential panel that was designed and built 15 years ago, have a commercial or a commercial fire, an FACP that was built 20 years ago. 20 years ago, cellular probably wasn't mainstream. 20 years ago, the internet probably wasn't mainstream. 25 years ago, it probably wasn't even a thought. So we're taking those systems that weren't designed to work with today's technology and putting in a Telguard communicator that universally adapts to those systems and sort of brings them into the 21st century, sort of brings them into a point where they can communicate with a central station via IP if they desired. They can communicate and get out of that premise, get out of that facility via something else other than a phone line. In the US, we use AT&T and Verizon. And of course, in Canada, we have a roaming agreement where we can use all 4 major carriers, Rogers, TELUS, SaskTel, and Bell Mobility. The way that I like to think about the way Telguard works, we are a dialer capture device. We are a dialer capture device that transmits everything through our communication center into the central station. So you think of it as 3 hops or 3 different types of connections. So connection number 1 is going to be from alarm panel to Telguard. Number 2, Telguard to our communication center. We short label it TCC. And lastly, the TCC communication or delivery to the central station. So The connection between the alarm panel and the Telguard unit, it's very simple. It's a basic POTS interface. What does that mean? That if your panel is programmed to deliver over POTS, plug a Telguard into it and it'll work. We're gonna mimic everything that the panel is expecting out of a phone line connection. Handshakes, kiss-offs when it dials in, the audible dial tone when it picks up, everything the panel expects out of talking to a receiver, it'll get from Telguard. We are, I would say, probably by far one of the most versatile products in the market because we can actually communicate and adapt to most of the alarm formats that are in existence today. Contact ID and SIA put together are probably going to represent about 85 to 90% of the traffic that we have here in Telguard, just to be honest about it. But there are a lot of DMP format being used, a lot of old radionics, pulse formats being used out there. You'll be surprised how often we actually get questions about whether we can handle a 3x1, how to program a panel to do 4x2. And the reason for that is that because a lot of these panels don't have, they were designed, again, many, many years ago. And when Contact ID was perhaps not even a standard yet, you know, Contact ID, I believe, goes back to 1999. So imagine a panel that was designed way before that. And, you know, our customers know that Telguard is going to give them their best shot at being able to communicate with those formats. Once we capture the signal, we are going to use cellular or internet path to communicate from the Telguard device to our communication center. Now, one of the things that I want to make sure we're clear is that the hardware itself is what determines the carrier. So if you buy an AT&T unit, that's the only carrier it'll be able to work with. If you buy a Verizon unit, that's the only carrier it'll be able to work with. If you purchased a 3G unit, and gosh, well, with Telguard, we've had LTE units rolled out since 2016. So if you bought a 3G unit back in 2015, and of course still kicking around, there's no way to make it an LTE unit other than replacing the board itself. With Telguard, we're going to use by any means necessary approach, which basically means we're going to try data, we're going to try SMS, we're going to try anything to get that signal out of there. Just to give you a little bit of feedback, a little bit of information, right? When it comes to cellular, data is a lot cheaper than text message. Data is a lot less expensive overall than using SMS. The reason why Telguard still has SMS as a backup option is because there are times in which the data connection may drop for X, Y, or Z factors. Weather is one of those factors that could basically just take about a bar off your signal strength. Your usual signal strength will drop by a bar when there's a thunderstorm or a snowstorm or something along those lines. So Telguard keeps that SMS option as a backup in case the data connection doesn't work. We'll go right back into the SMS. One of the easiest ways for me to explain why we do that is if we have any iPhone users in the audience, it's sort of the difference between the blue and the green text message, right? You know, you can do the blue text message to other iPhones. Whenever you do that, it's using data. It's using a data connection. But there are times when you try, it's not getting delivered, and all of a sudden, boom, iPhone tells you, do you want to send this as a text? The reason for that is because it's a known fact that it requires a lesser connection to be able to send a text message. So even though that iPhone couldn't connect over data network because of low signal strength or whatever reason, because it couldn't connect to give you that blue message, it now gives you the option to, hey, let's use text message because there's a better chance that that will actually work. So if you're an iPhone user, you 100% get where I'm coming from. If you're an Android user, get an iPhone. I don't know. Central station delivery. Once we get the signals back to our TCC, we can deliver the signals to the central station through various different options. So we can do analog, we can do IP. So we can deliver to analog receivers, we can deliver to IP receivers, we can even deliver using XML posting, depending on the central station, the type of connection that we have, for a much, much faster delivery. So when you think about the overall picture, we're looking at a panel or a system that was designed 25 years ago. Of course, it's been working this whole time, so your customer is not going to want to spend $5,000 replacing it. They're not going to want to do that because it's working. Just make it work, right? You pop a Telguard in, and now you're giving that panel sort of a new life. You're not only allowing it to communicate over cell, but you're also allowing it to communicate all the way back to the central station via IP. When you do this, and this is something that we highly recommend, you're basically taking POTS out of the equation altogether. We still have a lot of units, a lot of customers out there that love Telguard, will use it on the front end to replace the phone line at the premises, but still use dial-up delivery on the back end to the central station. So we're promoting as hard as we can, yelling from the as loud as we can. Any chance that you get to replace that POTS with a digital or an IP connection, the far better off you're going to be. Now, the fact that we have that TCC, that communication center in the middle, kind of intercepting the signals and delivering them, it gives you a lot of different options. So because the TCC is in the middle, that's what we can do the link supervision. Because that TCC is in the middle, that's what we can choose IP delivery, or we can do a dial-up, or we can do the XML posting. Another thing is that because we have that TCC in the middle, we can also redirect signals without panel reprogramming. So there are situations in which the panel is working perfectly. The panel is working right as it should. All the zones are working fine, everything's working great, but we want to switch over to, say, a new monitoring station. We want to switch over to a different account number under a different monitoring station, taking over as a dealer for an account that didn't belong to you. Chances of you having the installer code or a way to reprogram the unit, sometimes it just doesn't happen. So with the TCC being in the middle, we have the option of replacing the phone number with an IP address or with a different phone number. And we have the option of replacing whatever account number we're grabbing from the panel and replacing it with the account number of your choice. So it gives you the option of redirecting signals, basically through remote programming without having to reprogram the panel itself. To talk a little bit about our communication products, and I'll just run through this really quick. Residential cellular series, we have a TG1 Express and of course a TG4, which is a hybrid. Now these units are come in a plastic enclosure and they are home control flex compatible. So going back to that theme of being a universal communicator and a communicator that can really pair up well with a system that is very old, take it over and bring it into today. Home Control Flex is an option that allows you to remotely arm and disarm your system. So taking it back to that concept, you come into a house, it's a house that's been built 25 years ago. They have a security system there. It works fine. It works well, but they don't want to have a phone line. They don't want to spend money on getting a fancy new alarm system and brand new zones and everything else. You pop a Telguard in there, you pop a TG1 Express in there. Not only are you giving him cellular option, not only are you giving him a faster IP delivery to the central station, but now you're giving that 25-year-old panel the option to remotely arm and disarm and get notifications from an application, from a mobile app. So even Android users can get a mobile app that works on this. From the commercial side of things, we have our TG7 series. And this will be on the commercial fire side, our TG7FS and our TG7FP, which I'll dive a little bit more in a little bit. From our commercial side, the TG7 and TG7A, the main difference between the two is just the chassis. TG7A is going to be for your safe and vault applications, that armored chassis. And of course, all of these products are going to be commercial listed. The commercial fire are going to have the 864, and the commercial burger are going to have their own respective commercial listing. They're all compatible with the TG-PAM, and they have the different link supervision options that are required for standardized security on the Berg side, or for the 60-minute or 5-minute on the commercial fire side. The TG7FS has been our flagship product. It is part of the fire line, but just wanted to kind of highlight it a little bit more. Available for, of course, AT&T and Verizon. Is compliant with all the different listings, CSFM, FDNY, down to the regional level. This is the unit that you want to use when you need to power off of the AC connection. This is a unit that you want to use when you perhaps need to use a TG-PAM for additional zones. Basic layout, not going to go into too much detail for it. TG7 UBL is the product that you want to use when you're transitioning from an older Telguard into the newer Telguard. So if you are one of those customers that has been with us for a while, and you purchased and installed a Telguard unit back in 2015, and it happened to be a 3G unit, and you're now facing the sunset coming up in February, you want to replace that TG7FS unit, let's just say with a TG, with a newer version of it. TG7 UBL gives you that option. It's not only is it cheaper because obviously we don't have the chassis, we're just giving you the board and an antenna, but it also makes the installation a lot easier. If you deal with fire, you know what a pain in the neck it could be to try to get new installations, run new wires, or do anything along those lines, when all you have to do is disconnect, unscrew, and mount a new board in and just plug back in. It makes your life a heck of a lot easier. So TG7 UBL is the product that you use for replacing any of our TG7 products from older technology and bring them into newer technology. One of the things that I will say, and I want to make sure I take advantage of this opportunity, is whether it's with us or whether it's with anybody else, sometimes we do have a tendency of doing of changing what's in front of us, right? If we're upgrading from a 3G to an LTE, I'm going to change what's in front of me. What's in front of me? It's the panel, it's the Telguard. So let me go ahead and change the Telguard. Whether it's brand X, Y, or Z from different vendors, we're going to take the same approach. I'm going to change what's in front of me. I want to make sure that when you're doing this, whether it's Telguard or anybody else, make sure you check out the antenna. The antenna for the 3G unit will work with LTE. It is 100% going to work with LTE, but it's going to limit you in the frequencies that it can use. So if you get out there and replace a 3G TG7FS and use one of these boards, and you replace the board and you get it up and running, activated, it's giving you great signal, but you don't change the antenna, you are going to see some changes come February of 2022. Why? Because if it's AT&T, you're going to see some frequencies being turned off or being turned away to something else that the antenna itself cannot handle. So you want to make sure that if you are replacing from 3G to LTE, you check out the antenna and you make sure that it's a wideband antenna or an LTE antenna that covers the right range for it. One of our newer products is the TG7FP, and it's really just a basic approach to it. If you want to do sole path and you want to be able to power from the panel, this is the unit that you get. Anything outside of that application, you go with the TG7FS. It's as basic as it gets. So what we've done is we've stripped out the components that make it more expensive. There's no battery charger in there. There's no AC connection. There's a couple of different other components. There's no extra phone jack in there. There's a couple of components that we've extracted in order to minimize the cost and give you a very focused unit that turns out to be a very economical solution for the communication of fire systems. Recently, we introduced the Dual Path series, which is taking our Telguard products and adding an Ethernet communication path. Very much, very similar in form factor and very much the same as far as visually as the TG7FS. Big difference is that instead of having a phone jack for an incoming telephone line, we have a jack for the Ethernet connection. It gives you the option to dual path or sole path as you best see fit. So it gives you that option. So now you have three options. You want to do sole path, FP. You want to power from an AC connection or use a TG-PEM, you go with a TG7FS. You have an internet connection you want to take advantage of, you go with a TG7FE. I mentioned the TG-PEM a couple of times. What is a TG-PEM? Well, what does it do? Well, it serves a couple of purposes. I believe that the main purpose and the real value in the PEM today and moving forward is the fact that it allows you to expand inputs. So it basically takes and adds up to 8 inputs per PEM and adds them to whatever device it's connected to. So if you're connected to a fire system, it's going to give you the option to do 8 inputs. Now, it is UL 864 list. It is listed to be able to wire into outputs of an FACP for your 3 basic connections. So you can have your fire alarm, your trouble supervisory wired into the PEM, and the PEM connected to the TG7FS or TG7FE will relay the information over to the central station. So through programming, we can actually take a system that was never meant, doesn't have a dialer, was never meant to be remotely monitored, pop in a Telguard product with a TG-PEM accessory and make it so that it translates and it sends out the 3 basic signals that you would need for fire. So with that, I think I pretty much covered all the basics that we wanted to cover. And we have some time for some Q&A.
Excellent. Daniel, I really appreciate the information that you shared. It's always great to hear all of the information that you have about our past technologies, about where the industry has been, and then where things are going to be moving forward. I'd like to open it up to anybody who has questions. I've already got a few here. The first one by James. Do you have a white paper to help explain to customers the transition away from POTS and the issues with reliable communications? And for that, we do have kind of an end user oriented product guide. And I'm just going to share a link of that right here. And that'll get you to our website. If you go to the Telguard website and go to the TG7FS page, you'll see under the certification and other resources a TG7FS marketing material. And that's a great document that you can use to share with the end user of the product and help explain to them why cellular is a great alternative to using a phone line communication path. The second question I have here is by Pat D'Angelo. Is there any actual programming of any of the TG series communicators? What I'm going to take that as is, are you able to use a Telguard communicator to program upload or download to the panel? And we actually do have what is the Telguard virtual modem. It's a great piece of technology that allows you to remote into the Telguard communicator. And using either, if you have a Honeywell communicator, you can use their Compass software, or for DSE, you could use their DLS5 software and use that to remote into, as I said, remote into the Telguard unit to perform program panel changes from anywhere in the world. So as long as you can access that Telguard unit with the virtual modem, then you can use either Compass or DLS5 to reprogram that panel however you need it to. And then I see a third question here by Pat. Is the replacement TG7 UBL plug and play, or does it require programming? And yeah, it's pretty much plug and play, but you will need to update the customer's information, or if you need to into the new piece of equipment. So what we have is, if you go to the Telguard dealer portal, you'll bring up that particular account, and there is a replace feature where you'll type in the serial number of the new communication motherboard, and it'll transfer all of the data from the old motherboard over to the new one. So that way you don't have to do any reprogramming. It'll have all the same information as the previous unit. So that's the easiest way to transfer all the data. But if you didn't choose that path, then you would just go and register it just like a brand new unit. But once that's done, it's unscrew the old board, screw in the new board, replace the antenna, the battery connections, the data port, and then send a couple of test signals to test it out, and you should be good to go. So pretty simple replacement, as long as you've already transferred all of the customer's data over to the new unit. Yeah, are there any other questions that people may have? And again, I do want to say thank you to ESA for giving us the opportunity to speak today. We always want to put ourselves in a position where we can be training our dealers, our AHJs and fire marshals about cellular communications, because we do believe that it is a very reliable and efficient way to communicate alarm signals. Oh, you're welcome, James. But yeah, I'll leave it open for a couple more minutes to see if there's any other questions that somebody may have. We still have a few minutes left in the presentation today. One thing I do want to iterate on, we talked about it fairly briefly, is the capability of the, oh, we have a question. Where are Telguard communicators made? We actually are made out of Mississippi now. So all of our manufacturing is coming out of there. Corinth, Mississippi is where you'll see all of our equipment being produced. I think that's really nice to see that all of our equipment is American made, and all of our support, sales, customer service, and tech support and engineering is all in America too, all in the States. Can more information on LTE-M be found on our website? Question by Sam. And yeah, you'll find data sheets on all of our products on Telguard's website. And you'll just, if you have a particular product in mind, you can go to it, and in there you'll see a product information and instructions drop-down menu where you're going to see a brochure for that product. So it's a good place to learn more information about that particular communicator and some of its features on LTE-M. Right now, the LTE-M chipset is available on the TG7FP and TG7FE. So if you're looking for more questions or more answers about LTE-M in general, you can go to those data sheets. Oh, also, there's a new blog post specifically about LTE-M on telguard.com, so you can learn more there. Another thing I want to touch on real quick are the sunset dates. So we mentioned that AT&T is going to be sunsetting their 3G network in February of 2022. And I want to iterate that Verizon will be sunsetting their CDMA network in December of 2022. So there is still time, but to get your equipment upgraded before then. But I will kind of press that it is a process. So you might start seeing some of the 3G units start to drop down in signal strength if AT&T is working on upgrading existing technology in that area. So we're always trying to motivate our dealers to begin to address the upgrades as early as possible to work with their customers there. And one good way to do that is by sending out flyers to all of your customers. And we have a consumer sunset document that explains what the 3G or what the CDMA sunset is. And it's a great way to kind of give some credibility, explain to them why they need to upgrade their existing equipment. Something that you can easily input in or embed into your invoice, just an extra letter that explains it. So that way you can call on them later and schedule a time to upgrade that equipment. If you have other questions down the line and you want to talk with a Telguard sales rep, you'll find all of the Telguard sales reps contact info on our website. So if you go to telguard.com, you'll see the sales button in the top right-hand corner. And there you can see, just depending on which state you're in, who you can chat with. And I recommend reaching out to your sales rep about anything related to upcoming products, the TG7FS, TG7FP or FE, the newer ones, or any other residential, the TG1 Express. Or if you're working on your upgrades, it's a good time to chat with the sales rep to see, make sure that you have a list of the accounts, understand the most cost-effective way to upgrade them, and make sure that you get them all done in time. Let me see if there's any other questions here before. Let's see. Oh, I have one more question. What does the M in LTE-M stand for? Daniel, do you know the answer to that? Is there an M? Is there a reason why they have M at the end of LTE?
Well, it's really catering to the machine-to-machine world, right? So that's where that comes from.
Okay. Yeah, I know that.
Just to follow up on a question from Sam. Sam, you got my email address. So if you want to shoot me an email, I can send you some specific information about that as well. It's technology it's been around for a couple of years, but it's definitely the way to go when it comes to the IoT world. Great.
Okay, perfect. Well, I think that's it for today. We were very happy to give this presentation. On behalf of Telguard, I want to say thank you to everybody who participated, who sat through this presentation, and thanks again to ESA. I really appreciate the work that you did today as well, Daniel. If you have questions later on, please reach out to us and we'll be happy to work with you moving forward.
Okay, thank you again for everyone who attended. Thank you again, Daniel and Marshall, for your great presentations. And thank you again to all the attendees. We'll see you all next time.